Thank you for the time. It is very honor to have a presentation for the German people. The Tokyo Institute of Technology merged with Tokyo Medical and Dental University, and the name was changed Institute of Science Tokyo last October. So now we are at the Institute of Science Tokyo. And the laboratory for zero carbon energy, it means the nuclear. You can understand. Because the zero carbon, one of the very important option to reduce the carbon dioxide emission is nuclear power. So our laboratory, zero carbon energy. Also, we are studying solar, wind turbine, and hydro also. But I belong to the nuclear power plant members. Next, please.
Yes, that works.
This shows the restart status of Japanese nuclear power plant. In operation, red one, colored red, 14 nuclear power plants. And review for the safety review, okay, the 3 nuclear power plants. Under review, 7 power plants. Preparing to the safety review, 10 plants. But we decided, Japan decided 24 nuclear power plants decommissioning. Because safety measures, it takes a lot of cost to restart the operation. It's a lot of huge amount of construction, wiring, piping, and also a lot of additional such ice, earthquake, anti-vibration support, such so on. So, firstly, pressurized water reactors has start in operation for the Kyushu area, the Sendai nuclear power plant, 2 plants, and Genkai, and Ikata also. And also Takahama, this is a Kansai Electric Power Company, Takahama, Oi, Mihama. And also Kashikariwa TEPCO's plant 6 and 7, safety review is okay, but the very important special bunker facility for airplane crash is not end the construction. So the restart is not available at that moment. And also Tokai Daini is also the boiling water reactors. It's under construction of the safety measures. And the Rokkasho reprocessing plant for spent fuel reprocessing is, the safety review is okay, but they are constructing the safety measures to support the earthquake, also the airplane crash. It takes about 1 year and a half. It takes. So Onagawa nuclear power plant, Rokkasho reprocessing plant factory will be start in commercial operation 1 year and a half. And also the last December, Onagawa Unit 2 restarted. This is the boiling water reactors. So today, and also the Mihama is also just restarted. Mihama, not Shimane, also this is a boiling water reactor restarted. There are 2 boiling water reactors restarted. Next, please. This shows the panorama view of Tokyo Electric Power Company, Onagawa nuclear power plant. Today, I'd like to explain how the Onagawa nuclear power plant restart. This is the nearest plant in epicenter, and also the very high tsunami attacked. But the plant, unit 1, unit 2, unit 3, almost very, very a small effect to the safety measures. Because the ground level of the nuclear plant or Onagawa site is 14.80 meters. At the start construction of the Onagawa nuclear power plant, Tokyo Electric Power Company set the specialist meeting with including the Tohoku University's tsunami and earthquake professionals. So finally, Vice President of the Tokyo Electric Power Company decided the floor level 15 meters. The concrete floor 20 centimeters. So the ground level is decided 14.8 meters. This is because the Onagawa nuclear power plant protects the tsunami. Next slide, please. This is the March 11, 2011, Great East Japan earthquake occurred. The largest earthquake ever recorded in Japan was magnitude 9.0. This shows a scenery at the Onagawa town. The people suffered from the very strong earthquake and tsunami. A lot of people, about 20,000 people died or lost their about 20,000 people died. This is Onagawa towns, very, very sad to the very strong earthquake and tsunami. Onagawa nuclear power plant is the nearest, the epicenter of the earthquake. Next, please. And this is the fourth largest earthquake in the world. Very, very strong earthquake. So fourth largest earthquake in the world. At 1446, magnitude 9 earthquake occurred. So far, 20,000 people are killed by the earthquake and tsunami. 300 billion US dollar damaged to estimated. No one killed by the radiation at Fukushima, but the neighbors suffered from the radioactive materials. This is the Dr. Mizumachi. When he visited the United States, he gave the helmets for the children who are grown up 15 years. In Japan, all time, 15 years old, the boy is the actual adult, very, very young adult. and health without no damage, health, and getting their his life is glorious. So the Dr. Mizumachi gave the nuclear power plant to the director in the United States such a helmet to suppress such a natural disaster to the nuclear power plant. This shows the Fukushima Daiichi areas, and it was a very, very strong tsunami attack. これ難しいか。I think it's a PDF file, so it's don't move it. Next, please. This is the tsunami getting over the seawall at Fukushima Daiichi. But this seawall height is 10 meters, but the tsunami height 15 meters. So the tsunami easily go over the seawall. And there are very, very similar strong earthquake and tsunami at 855 and 817 feet. As the Emperor Seiwa, 56 Emperor Seiwa, such a very, very similar Jogan tsunami, 869 Jogan tsunami occurred. And also 1611 Keicho tsunami, and 1896 Meiji Sanriku tsunami, 1933 Showa Sanriku tsunami, and 2011 East Northeast very big earthquake and tsunami occurred. And the Emperor ordered that all victims by the tsunami have no responsibilities. I have all responsibility because God punished his activity as the Emperor. Do not take any tax from these areas attacked by the tsunami. I'll pray the Ise Temple, pray the God, and the offers should go there and help all victims clean up the mass of rubble. So this is a very, very clever judge to remove the garbage and restart the people to the farmer or fisherman that continue to their lives. Next, please. This shows the epicenter, the map. Onagawa nuclear power plant is the nearest nuclear power plant at the epicenter, and Fukushima Daiichi and Daini nuclear power plant, and Tokai Daini nuclear power plant. There are a lot of nuclear power plants along the east coast of the Honshu Island, Honshu area of the Japan. East coast of northern area in the main island of Japan is seriously damaged. As of the August 11, 15,810 people are dead and 4,060 13 people are missing according to the Fire and Disaster Management Agency. Next, please. And this shows the nuclear reactor epicenter of the earthquake, Onagawa nuclear plant, Onagawa, Fukushima Daiichi, Fukushima Daini. There are a lot of nuclear power plants in operation at that time. 11 reactors under operation were automatically shut down to insert the core for the control, and shutdown succeeded. Onagawa 1, 2, 3, Fukushima Daiichi 1, 2, 3, and Fukushima Daini 1, 2, 3, 4, and Tokai Daini. All the nuclear power plants succeeded the shutdown. 3 reactors under periodic inspection, Fukushima Daiichi 4, 5, 6. Around 1 hour later, after the tsunami hit the nuclear power station above, following the reactor went to could shut down. Onagawa 1, 2, 3 external power and seawater pumps were alive. This is very, very important because the ground level is 14.8 meters. Fukushima Daiichi ground level only 10 meters. 5 meters, the difference is a very, very difference to the suffered from the tsunami or protect the tsunami. Fukushima Daiichi 5 and 6 emergency diesel generator was arrived. Fukushima Daini 1, 2, 3, 4 external power was arrived. Tokai Daini emergency diesel generator was arrived. So it is very, very important. Even in the strong earthquake and tsunami, the AC power or supplied from the emergency diesel generator is very, very important to protect the core damage, to protect the core meltdown. The problem comes with the Fukushima Daiichi 1, 2, 3, and 4. Next, please. All 3 units attained cold shutdown at the Onagawa nuclear power plant. Unit 1 cold shutdown 100% in operation. And Unit 2 startup phase at the nuclear power plant at 2 o'clock in the afternoon. And Unit 3 100% in operation, attained cold shutdown. So all the nuclear power plants attained cold shutdown. Shutdown reactor okay, cool down okay, and contain the radioactive materials okay. It is very, very important to get the AC power from the transmission line or emergency diesel generator. And also the tsunami protect wall is very important. Next, please. Even in the entire Oshika Peninsula had sunk by 1 meter. The ground level at the Onagawa area, it's called the Oshika Peninsula. Ground level decreased 1 meter. Very, very huge areas. Ground level decreased 1 meter. As I explained that the ground level is 14.8 meters, but 1 meter decreased. But the tsunami height is almost 13 meters. So the tsunami didn't enter the nuclear power plant. You can imagine ground level decrease 1 meter. But 50 meters height of ground floor level is very, very important. And it is very important to continue to cool down the reactors. This is in Japan, almost all the nuclear power plant was ultimate heat sink is seawater. So the intake, the pump, and the heat exchanger and the pump And then by using the heat exchanger, cooling the fuel in the reactor was attained. Next, please. And also the external lines are maintained, and emergency power is also available. Unit 1, Unit 2, Unit 3. Earthquake resistance reinforcement work or piping in 3,600 points has been completed. Tokyo Electric Power Company has already reinforced to protect the tsunami before March 11. This is the key point. Next, please. And also, nuclear disaster prevention training was also carried out at the Onagawa nuclear power station. They are trained a lot of times how the people such a disaster comes, how they act as the professionals. They are trained a lot of times. And this is a headquarter meeting room. So all the communication tools are already installed. Next, please. And the residents of Onagawa town damaged by the tsunami, very, very strong tsunami, arrived at the PR center of the Onagawa power station. And the Tokyo Electric Power Company officer welcome to the Onagawa town's people, and they escorted to the gymnasium. Next page, please. They guided everyone to the gymnasium and spent 3 months in evacuation shelter its use as an evacuation shelter. 364 people lived for 3 months. Everyone stayed gymnasium 3 months. And the food was supplied from the Tokyo Power companies. Next, please. And the Tokyo Electric Power Company received a Nuclear Contributor Award from WANO. Also, IAEA report remarkably undamaged despite harsh conditions such as distance from the epicenter, magnitude and duration of the earthquake motion. 3 reasons for the WANO award. First, they responded to the emergency and made preparation in advance. Second, they safely performed cold shutdown of the nuclear reactor despite the huge earthquake and tsunami. Third, they welcomed the local residents and overcome the difficulty together. Next page, please. And based on the ISO overseas survey, I visited the Onagawa nuclear power station and visited and gave advice to the based on the knowledge from the ISO in the United States. And exchange opinions on safety measures. Next, please. A general meeting of the determination, including the people of Onagawa town to complete the safety measures construction work for Onagawa Unit 2, December 2022. 3 years, 2 years before the restart commercial operation. You can see that a lot of flag, and it is a fisherman's flag. Fisherman use the flag at very lot of fish got. Then fisherman flag the ship. So the fisherman and Tokyo companies, officers, engineers, operators get joined one. So this is very important to support. They get the support, public acceptance of the Onagawa Dam people. This is a very important key point to restart the boiling water. First boiling water reactor restarted. Next, please. So, as I said, huge amounts of construction work for the earthquake resistance, reinforced work, and fireproofing of cables. Pipes 5,000 meters, cables 850 kilometers. It's Onagawa, the distance, Onagawa and Kyoto city. And the conduit 80 kilometers. And scaffold, but 300,000 cubic meters. It's at the height of about 100 kilometers. This is a support when the construction engineer used such a scaffold. And also the improved fire resistance, piping and cables. Earthquake resistance supports at 9,000 supports. So this is about 3,000 earthquake resistant reinforced was conducted to restart the nuclear power plant. Next, please. This is a piping the filter vent, seismic reinforced steel supports for the piping. I recommend the Japanese utilities as a member of the Nuclear Regulatory Authority advice professor member. And I recommend to install the filter vent system. Green, there are three filter vent vessels you can see, green one. And the piping is blue. But light green is the components to support the anti-earthquake vibration. There are huge amount of steel was used to support, to protect the earth, earthquakes. Next, please. And the gas turbine power supply car was installed at the special garage at in the nuclear power stations. And also diesel fuel tank installed underground. Diesel fuel tanks installed underground construction has already finished. Next, please. This is installing freshwater storage tank and large capacity water pump vehicles. This is the supply the water, clean water to the nuclear power plant. Very freshwater tank about 10,000 cubic meters were constructed. Next, please. This is a Shimane Unit 2 at the Chugoku Electric Power Company, Japan. Resumed the commercial operation this January. Shima Nuclear Power Plant Unit 2 at the Matsue, Shimane Nuclear Power Plant Unit 2, Shimane City, Matsue City. And this is a local government headquarters building exists, and which was started this December and start commercial operation in January. Next, please. And Nuclear Regulatory Authority Japan reviewed the Tomari Nuclear Power Plant Unit 3 is nearly completed. It's got the okay to restart. And on the January 24th, NRA official said there have been no additional points raised. NRA believes that Hokkaido Electric Power Company completed its explanation, and they got okay from the nuclear regulatory authorities. This is a pressurized water reactor, Tomari Nuclear Power Plant 3 unit, and it is a latest pressurized water reactor in Japan. The reactor stopped 30 years, and it takes about 2 more years to restart commercial operation. Because the seawall should be reinforced, it takes about two years. It is very, it takes a lot of cost and time to install such a strong seawall. Next, please. So we are just research. We are also get a contribution award from the installation of filter content venting system and the publication of the completion of the ISO overseas Arara visits nuclear power plant people. ISO members go to United States, European countries, and also visit Japan. I also got the award to support to install the filtered content venting system to remove the radioactive materials to vent, clean the air from the venting system. Next, please. Oh, it's the first again, first. And that's all. This is the no, it's complete. And also, we are deeply grateful to the IAEA for activities to verify the related to tritium treated water at the PRA 16. I attend the interest conference, IPRA 16. And I thank the IAEA people to the activities to verify the release of tritium water safety. This is very important. Next, please. And also, I attend a television program, and I explain the how the Fukushima Daiichi nuclear power plant decommissioning to accelerate. Next, please. And this is the fuel debris retrieval work plan and negative pressure management. I attend such a air application system unit, and I probed the Tokyo Electric Power Company to install such a air clean systems and use the robotics to remove the melted core debris from the primary containment vessels. Next, please. This shows heavy-duty robotics installed, and also had already developed the application system. Very high decomposition factor realized. An access door should be installed through the PCB wall, and radioactive dust inside the enclosure will be using the air application system. Next, please. And this is the development of the compact application system. It is a mobile type. It's easily moved to the working area by the engineers. Next, please. And this is the key point, the nozzle of the application system. Very high performance nozzle type, steam injector nozzle type scrubber was used. The flow rate 141 cubic meter per hour, and it's used about 24 nozzles. It over the 2,000 cubic meter per hour. This is a very high efficiency radioactive materials removal scrubbing nozzles. Next, please. This is an actual test of the installing the ripple plates, reduce the droplets. The application system in the water is contaminated by the suction by the radioactive material dust. So getting the contamination higher and higher. So to stop the very tiny droplet out of this application system, and by using the such a rippling plate, we attained such a high performance decontamination factors. Next, please. This is the application system. The flow direction was 180 degree changed. So the high centrifugal force generated about 2,000 G as realized, and a lot of tiny materials such as debris powders also should in the air to transfer from the water phase. Next, please. And this is also the multi-metal fiber plate. This realized decontamination factor 9,000. The fiber diameter 30 micrometer, 12 micrometer, and 2 micrometers. 3 layers. It was the decontamination factor of 9,000. Next, please. So it is such a also the shelters for the near the nuclear power plants. Application system is useful for the nuclear reactor accident evacuation. Also the such a nuclear weapons attack. It is very important to clean the air, even in the contaminated by radioactive materials. Next, please. And my explain matter changed. Just before Tokyo Metropolitan area blackout on March 22, 2022, at the Tokyo Metropolitan area, 35 million people live. And that day, the decreased solar panel output due to the cloudy weather and even the snowfall and lost coal power plant because of the strong earthquake. So shortage of the new, electricity has occurred. Because the Tokyo Metropolitan area, 14.3 gigawatts electricity from the solar panels. But the cloudy is almost 1.7 gigawatts. So it's lost 12.6 gigawatts. It corresponds to the 12 nuclear power plants of the, 1 gigawatt. And also the wind is very, very small on March 22. So this is the very, very high risk condition to the metropolitan area blackout. So the minister of the METI, the Minister of Economy and Trade Industries request, please do not use electricity. Please shut down the electricity units such as refrigerator, washing machine, air conditioners, all the electricity need components should be shut down. So very, very, very small difference. Tokyo area saved to suffer from the metropolitan area blackout. The people, Japanese people in Tokyo metropolitan area switched off such electricity components. This day, I go back to from university to my house. At the Ginza area, the center of the very, very famous Tokyo area, there's no neon sign. There are very black, very, very black. Where's the Mitsukoshi department? There's a very famous building here. Every direction, it's only getting black. And also some of the light of the car was recognized that where I am in the Ginza, where I am. Next, please. So I think the nuclear power plant is very, very important to protect the blackout. And also, we propose the utilities in Japan to install the air filtered content venting system, and also the water supply system, and also the ultimate heat sink mobile car. There are heat sinks in the mobile car, and heat exchanger and pump utilized. Even if the seawater pump suffer from the tsunami, the mobile ultimate heat sinker is can and cool the supply the cooled water from the cooled by the seawater. This is a full strategy of the station blackout to protect against severe extent PW in Japan. All the nuclear reactors add such a device to protect the severe extent. Next, please. And this shows the core damage frequency before and after the safety measures. It was recognized, evaluated, about reduced 3 orders of magnitude compared to before the measures. Even it's the greatest risk is loss of ultimate heat sink, TW sequence. By using the filter vent venting system, pressure in the containment vessel reduced, and also the pressure in the reactor vessel also reduced to flow out the water, high pressure water in the containment suppression pool. And the filter vent venting system, it's called early vent system. It's a core, no nuclear fuels is damaged, but to reduce the pressure in the containment vessel, it's easy to inject the water to the containment vessel and the reactor vessels. So the TW sequence risk is 3 order reduced, 1,000 reduced. And these risks, you can see the total risk is, this is a long scale. So the filter venting system effect to the reduces 3 of magnitude. Total, also the total CDF also reduced 3 orders of magnitude. So it's a key point of the risk reducing the filtered containment system. Next, please. So merits of installing a filter containment system: never pollute the local area again, and to protect the people. Radiation exposure in the PAZ area, particular action zone, PAZ can be prevented, and the area within the UPZ, about the radius within the 5 to 30 kilometers, can be staying indoors. There are installed air shelter at the PAZ zone. This is a plastic film type shelter, supply the clean air from the air purification system. And such a air tent was installed within 15 minutes. So a lot of people, residents in nuclear power plant, escaped from into such air shelters. This was also already installed at the Umaizaki City near Hamaoka nuclear power plant. Next, please. And also the passive startup of filter containment system was developed by using safety relief valve. We asked Okano valve firms to develop the very low pressure safety relief valve. Main steam line survey is it's worked under the pressure of 7 or 8 megapascal, but this SRV is below the 1 megapascal, and we try to develop, and we succeeded. Without human action, SRV automatically open by the pressure and maintain the open status, because such a device can grasp the valve stem rod kept open. So no one make such a open operation is needed. Only the SRV automatically open the valves and start the operation and reduce the pressure of the primary containment vessel and also the reactor pressure vessels. Next, please. And also, we succeeded to develop by xenon absorption systems. Xenon is one of the dangerous materials during the severe accident. We can capture even the xenon by using the silver xenolite materials. We succeeded. Almost the xenon was captured by the silver xenolite. The AT2SPBS adopts both the iodine and xenon. Impressive the asset value of the power plants by eliminating the need for emergency evacuation. We'd like to realize no evacuation-free plant should be needed in the future, very, very near future. We are continue to develop such a removing the iodine and xenon. Next, please. And this shows the greenhouse emission gas ranking. It shows the emission mass of carbon dioxide by using, when we use the 1 kilowatt-hour electricity. And 1 kilowatt hot water pot use 1 kilowatt-hour electricity, and in Japan, 540 grams carbon dioxide generated by such a 1 kilowatt electricity by using the coals or natural gas fossil plant. It's the weight is almost of 540 grams. Is almost the same as such a pet bottle tea. And also, Germany 472 grams. At that time, Germany's nuclear power plant in operation. Then today, Germany nuclear power plant greenhouse gas emission increased, and also the Germany is Japan and China, between Japan and China. I think so. The Germany increased the carbon dioxide emissions increased. And the best choice is, you can see, Norway, 100% hydro. And Swiss, Sweden, France, Canada is utilize hydro and nuclear. This is the best choice. The greenhouse gas emission factor is about 1/10 of the Japan, Germany, United States, and China. So this is a solution to attain the carbon dioxide emission reduced, carbon free, carbon neutral conditions, to realize the carbon neutral conditions. It is very, very important. I make this figures, this graph by using the Excel by myself. I got the database, global notes, pay money by credit card, and input the data of the total carbon dioxide emission 1 year, total electric power generation 1 year, and divide it, and the carbon dioxide emission per 1 kilowatt hour. This is a graph made by myself. Next, please. And so today, I'd like to talk to the Germany people how the nuclear power plant is very, very important. Solar panels capacity factor is only 30% in Japan. I think the German more or less about 10% capacity factor. So even if the facility of supplying 100% of electricity at kilowatt base, kilowatt peak power, but 24 hours or 1 year, the electricity supplied kilowatt hour base only 13%. Also the wind. In Japan, wind is very weak. So the only 25% capacity factor. So even if we build the facility supplying 100% of electricity, only 25% share. So 200% of solar panels and wind, we can get the 38%. 13% plus 25% get 38%. And hydro attained, so almost 5%, 50% green electricity without carbon dioxide realized. But it's cost very huge. It costs very huge money. 100% for solar panels, 100% wind, 200%. It's and it is very important. When cloudy and no wind day, almost all the solar panel and wind reduce the power output. So we need the thermal power plant, hydro plant, and nuclear power plant can supply 100% electricity in Japan. There is no grid connected. Germany connected with French, with Switzerland, so on. So Germany people can sell and buy the electricity very easily. The lot of grid connection is installed in European countries. But in Japan, there's no connection with Korea or Russia or China. So in closed electricity grid system, when the cloudy and no wind day, hydro, nuclear, thermal can supply 100% electricity using the hydroelectric, nuclear, and thermal power. You can recognize very, very important. If such a electricity system supply 100% hydro, nuclear, thermal, there's no need to solar and wind. And in future, thermal power plant should be replaced nuclear power plant. So the hydro and the nuclear power plant can supply electricity 100% in Japan. But maybe the 2050 in the middle of this century. So the nuclear power plant is very, very important. Next, please. And this is our university. They bring such a concept of the procedure, load flowing SMR, small modular reactor, and middle modular reactors. This using the reactor internal pumps, post recirculation in the core, not natural recirculation. And the new power output increased 300 megawatts to 100 megawatts. And also, by using G10 made by General Electric, the diameter of the hairpin is small. So the operating is possible about 30%. So 800% to multiply 1.3, it can supply the electricity 1,000 megawatts, 1 gigawatt electricity was supplied. You can see this type of the reactor, post reactor is compared with the ABWR. This type of the reactor specific weight is about half 1 kilowatt hour ton by 1 kilowatt hour electricity. Because the building, it's reactor building and also the turbine building together. And using the shell ship hull structures introduced. Next, please. So this is the conclusion. From the lessons of Fukushima Daiichi accident, Japanese nuclear power plant has installed safety measures and 14 nuclear power plant restarted. BW Onagawa 2 and Shimane 2 starts commercial operation. Kariwa 6-7 needs local government agreement. And also finished the construction of the bunkered facility for the airplane to protect the airplane crash. Pressurized water reactor, Tomari 3 third unit will also reviewed by next April. This year, they got approved to restart. Green transformation GX, which aims to the shift to the decarbonized society, nuclear power plant should be utilized to the maximum possible extent. Decarbonization, stable supply of the energy, and economic growth is attained by the nuclear power plant. We thank nuclear radiation protection expert in ISO in the United States members. And the ISO system is not only the United States, European countries, Japan. So a lot of countries join the ISO system. The information system will provide exposure to reduce workers' exposure. It is also the safety issues. Support restart and stable operation by policy of ensuring safety and ARARA as low as reasonable achievable. Thank you for attention. That's all. Thank you very much.
Thanks to you, Professor, for your interesting presentation. I propose I will ask a few, let's say, prepared questions, and then we can go into the 3 questions and answers. As you see, there's also applause from your virtual applause from your listeners. Maybe going back in your presentation, you had this beautiful map at the very beginning. I will jump back with all the nuclear power plants in Japan. And my question is, how many more nuclear power plants are we going to see restarted? I mean, you have on this map that there are 24 nuclear power plants to be decommissioned. Is that final? Or are there very, let's say, hard technical reasons why you can't restart those nuclear power plants? Or is it more about, I don't know, economics or politics that those nuclear power plants are not restarted?
In Japan, the Japanese people agreed when the same number of the plants after the decommissioning, new nuclear power plant will be possible to start construction. But it takes a lot of time. So in Japan nowadays, decided to one plant decommissioning. New one plant should okay to start construction. So in Japan, before the March 11 accident, there are over the 50 nuclear power plants in commercial operation. But after the March 11, about almost 5 years, there's no nuclear power plant in operation in Japan. There's totally no nuclear power plant in operation. But one by 1 year, some of the nuclear power plants restart. And also, I think the 24 more plants, I think it is possible to make new nuclear power plants. And in future, the people are more affirmative to restart the nuclear plant. The people recognize a very small, very safety measures is perfect, getting perfect. The Japanese people agree more nuclear power plant in Japan. But in Japan, there's a very small area, total area very small. And the flat area is 30% in the total area of Japan. About 70% is mountain in Japan. So in Japan now, cut off the mountain tree and build the solar panels power station. So I think it is very, very bad for the carbon neutral, because when the tree cut off, there's no capture the carbon dioxide to turn the oxygen and also some organic materials. So mountain tree or grasses is very, very important to maintain the carbon dioxide emission, reduce the carbon dioxide emission. So I think it is very key point to where we can construct the new nuclear power plants. So I think checked, and there are some of the nuclear power plants have the area for the inside the nuclear plant site. About five or more plants, it's okay to start a new plant. And also the Onagawa to the Higashidori area, there are about 10 or 20 nuclear plants. The area is also exists, but there are some crack for the countermeasure you needed such areas to such a fault, such a ground movement. So this is by using such a technology to protect such a fault to crack measures. I think it's more nuclear power plant than construction.
Mm-hmm. Thank you. To the audience, if you feel free to raise your hands if you have questions. I will ask at least two more of my own. So you already talked about construction of new nuclear power plants. Before we talk more about this, my question is, how did Japan maintain the experience of operating nuclear power plants over the time of the shutdowns, because you know, you have all those people, on payroll. Did the operators just keep them on payroll for up to, I don't, let's say 15 years of idle plants, or did they start laying off the workers and then rehired them when the plants were restarted?
It's one of the key points to restart the nuclear power plant for a long time shutdown. So Japanese nuclear plant workers or operators, some of them to go to the United States, such as EPRI was some of the nuclear power plants welcome to the Japanese operator, such as the ISOE members support the Japanese operator to training. And also, Nuclear Regulatory Commission (NRC) supports such a reactor oversight process concept, such as how to keep the safety measures. It was also that. So we are thanks to the NRC members, also the ISO members. And after that, firstly, Sendai nuclear power plant restarted. And the other nuclear power plant or the PWR plant, operators, workers, support the Sendai nuclear power plant for the first commercial operation and get the experience to how to operate or how to maintain the nuclear power plant on their own nuclear power plant. And also, even the boiling water reactor operators go to the PWR water reactor operation, join. And so even the change of type of the reactor, they can get experience in the operation and maintenance. And also in Japan, there are a lot of simulators, computer simulated accident actions trained by using the computer control rooms, almost the same as the control room, but they are computer some loss of supply cooling water or some emergency that emergency generator out of order, such so. The trainer trains such a nuclear power plant operators. There are almost all the nuclear power plant utilities, such a training center. That's all.
So a lot of work with the simulators to maintain and regain the experience. Okay. And another question is, Japan and the Japanese nuclear industry is very well known for building the ABWR reactor in a very short time, below 40 months, which is, I think, the record time for building large nuclear reactors in modern times anywhere in the world. And I wonder if the Japanese nuclear industry, after all those restarts have been completed, is interested in exporting this knowledge of constructing nuclear power plants very quickly abroad, because we have seen a lot of nuclear power plant projects taking very long and running over budget in France and Finland and UK and the US. So yeah, I wonder if the Japanese nuclear industry can show the rest of the world how to build nuclear reactors in time and on budget.
I think the Japanese utilities or Japanese nuclear power vendors cooperate with the German people. Today morning, I had a meeting with the Japan Society of Mechanical Engineers to the SMR medium small modular reactors and also the innovative reactors research group joined. It's joined at vendors and utilities and such university people. How the experienced people to the transfer the young generation people the technology experience. It is also Japan is it's a very important issue to restart and export the nuclear power plant. And also the Germany very high technology. It's a Kabel nuclear power plant, such on. So if you judge to restart to utilize the nuclear power plant, the Germany people is very clever and a lot of technologies. So Japan also supports their activities and also to work together to the restart of German nuclear power plant. I think it's all the people affirmative to support the Germany's nuclear power plant restart in Japan.
Thank you. And about the construction of new nuclear power plants, are there already some projects running or planned for the near future? So is there construction work ongoing?
For example, Mitsubishi Heavy Industry would like to construction at the Kansai Electric Power Companies. Kansai Electric Power Company has already started 7 nuclear power plants. But there are electricity shortage because the semiconductor factories utilize AI servers and data center. It needs a lot of electricity. So Kansai Electric Power has an intention to construct a new nuclear power plant. But the key point is the cost. Because in Japan, the human workers for the salary and also the lot of steel and a lot of components get to increase the cost. So my Tokyo Tech Science of Tokyo developed such a medium type modular reactors. The cost and simplifies the safety measures. The passive cooling system reduce the heat exchangers, pump, and piping, and also valves. So when I was in Toshiba Corporation by the Westinghouse company, because AP1000 very clever design, passive components utilized and reduce the pump, piping, and such cables and such a lot of things can reduce. About reduce about half, about 70%, such on. So this is a SMR also, the new scale also, simplify the safety system and increase the reliability and reduce the cost. So I think it's a key point. Also, the ABWR should be reduce the cost to applying the safety systems. And also the EPR of the France. Also, the EPR is very, very expensive. So they are planning to reduce the cost and they simplify the system. EPR2 has started their design at the French Framoton company, I think. President Macron ordered that such a using the nuclear plant.
Yeah, thank you. So any questions from the audience, from the rest of the audience?
So I would like to ask what Japanese nuclear power plants do you recommend for visiting? Are there ones that are like easy to visit for a guide, for a guided tour? So when I go to Japan, I'm usually in the Kansai area, and I would be interested, for example, to visit the KEPCO plants, and also maybe go to the Fukushima site as well. Do you know how to like make a tour there? Is it difficult?
I think it's possible. If you would like to visit the nuclear power plant, Fukushima Daiichi, and also the Kansai area, I can have the connection network to ask the utilities to visit the foreigners.
Okay, so maybe I can send you an email and then we can communicate. So because I really
so it's about 5 years ago, Taiwan students and professors would like to visit Japan, Fukushima Daiichi. The fish on the other foods are the safety or not. The students bring their survey meters. And they recognize the Japanese food, Fukushima area, even the Fukushima area is safe. They got the fish eat. And after that, they go to the Kansai area, Takahama plant. Please visit the Takahama area. The director of the Takahama nuclear power plant is my friend. And I asked him to the Taiwan people and the Taiwan students to visit the nuclear plant. And it's realized.
Okay.
Any further questions? In this case, another one from me. Are the ABWR reactors still up to date and certifiable today in Japan? Like, could you order a copy of an ABWR reactor and build it in Japan today?
Also, Hitachi G Bellnova, also HIABWR design. They are preparing the construction. And also Toshiba Corporation IBR, it's improved ABWR is design. So and also within two or 3 years, Kashiwa's Kariwa Unit 6 and 7, it's ABWR will be restart. And Shimane 3 third unit also restart, maybe. So there are several ABWRs in Japan. So the ABWR also restart in operation, restart in commercial operation.
Okay, so that's good to hear that they are working on updated versions of this reactor as well, because again, below 40 months construction time is just an insane pace and performance. So that's very great. Yes, Dominic, you want to ask a question?
Yes, one question about the LLBBR design. Where can I find more information about that? Are there any papers or general presentations about that?
LSBWR or the GXBWR papers? You mean?
Yes, exactly. That you showed.
I have presented a paper at ICAP 2024. I can send you the paper to you. Please send me an email. So I send back your to you to my paper to the presented material paper at the ICAP 2024. The plant, the concept is nominated one of the 10 best plant in the world. NS said, and also peer reviewers also passed the basic nuclear technology, the nuclear engineering design. My paper is published within a few months, I think. Also, this official peer-reviewed papers.
Okay, thank you.
Well, so we are at the 1.5 hour time. So yeah, if I don't know if you would like to say some closing words or closing remarks, now is the time. Otherwise, I will. So thank you very much, Professor, for joining us today. We, as you see, have seen there were people interested with questions to you, and we will also post the recording on YouTube, so you can reference it, and people who can't join today due to work or vacation schedules can watch your presentation later. And again, thank you so much for joining us.
Welcome. And also, I had a very, very interesting, had a nice time to have a fruit discussions. So in future, I liked all the Japanese vendors or utilities support the nuclear reactor restart in Germany.
Well, we hope the same. We do our best every day to make this politically possible in Germany, because as you for sure now, we have this law against use of nuclear power, but yeah, it's we'll try to change it, and when we succeed, we need a lot of input from Japan. And thank you very much, and have a nice day, and especially have a good flight to the US.
Yes, tomorrow. Tomorrow I will fly to the United States.
Thank you. Bye.
And after that, ICAP 2025 head at France. I joined also the ICAP 2025. Now to head at anti.
Understood. Okay, so then I will close the call, and I will also connect everyone by email who had some follow-up questions. Okay. One more thing I just saw in the chat, that there has been a question by David Gramatsky. I will read it for you. In the 90s, there has been a study by General Electric, Toshiba, and TEPCO for reactor pressure vessel replacement in boiling water reactors. is this something that is still considered today for long-term operations in Japan?
I know that such at that time I am also in Toshiba Corporation. That we are studying the replace reactor vessel, pressure vessel. It's construction is very heavy, but it's a technical point. It's possible. But nowadays, Japanese nuclear power plants use very high quality steel. This is very low damage by the neutron damage. So I think the Japanese reactor vessel can use about more than 100 years. So the very high quality pressure vessel is very important to reduce the vessel exchange, reactor vessel exchange.
Oh, okay,
and also,
that's great to hear. And what about the foundations and the containment building and so on, the concrete?
This building, it's a steel reactor building. It looks like a steel, but our concept is the ship hull structure. So the technology of to build the ship body. So two steel plate and connected at some ribs.
Okay.
This is a steel reactor building.
Interesting.
It reduces the cost, construction time, and increase kept the high quality of the welding, because it's a construct at the nuclear power plant vendor, and ship the nuclear power plant. This figure, the right figure, shows that such a ship type export from the Japanese factories.
Okay. Well, okay. Then thanks again for the answer to David's question. And yeah, have a nice day.
You too. Thank you very much. If you have some questions, I'll answer to some questions. Thank you very much.
Okay. Okay, so okay, so stream has ended, and I will okay.